Jesse, and welcome to the second video of my Python tutorial. We are going to talk about strings today, what they are, how to index into them, how you can slice them into pieces, and then we're going to go into conditions and branching, and then a live code example. They are letters, spaces, special characters, and digits, all the keys on the keyboard. And they are surrounded by a single quote or double quote. You can concatenate a string onto another string, which means add one string to the end of another string. We will go over input and output later in this video. Strings are also immutable, so once you define a string, you cannot change the contents of it without creating an entirely new variable. They are case sensitive. So a capital ABC is not the same as lowercase abc, and you can run comparisons on them. So lowercase letters are greater than uppercase letters. Lowercase letters are less than uppercase letters, so that would evaluate to false. So they are not equal because they are different characters. That is false. And then this is the not equals, so the exclamation point, it means not equal, and so that would evaluate to true because they are not the same characters in Python. Another useful operation is the len operation. Calculates the length of a string. So we have my string A, B, C, D, E, F, and then the length of it, we pass it in, would evaluate to 6. Length of an empty string would be 0. So strings are indexable. So here we have our string A, B, C, D, E, F, the length is 6. And then we index it, which means grab a portion of the string. So here S of 0 would be A. In computer science, the first index of a space in the computer, or where the memory of this string is stored, is always starts at 0. And then the last index is -1, or the number of characters minus 1. So we have S of 1 is B, S of 5, which is F, it's 5, not 6, because remember we started at 0. And then S of -1 would be F, and then S of -2 would be E. You may also slice a string. The syntax of slicing a string is square brackets, start, colon, stop, colon, step. The default start is always 0, default stop is the end of the string, and then the default step is 1. The step is the interval. So we have our string, and we want to get the first two characters. We give it 0 and 2 for the start and the stop, and we get AB. If we don't give it a start, we also get AB. And then we want to get 2 to 5, we get CDEE. If we want to get everything but the last character, we give it ABCDEE. And then another thing we can do is if you want to get the reverse of the string, you can set the step as -1, and it will reverse S. So we get the reverse of ABCDEF. And then another thing we could do is check if a word is a palindrome. So a palindrome is the letters are the same whether they are written forwards or backwards. So we have the name Hannah. And now let's reverse Hannah. Hannah. Awesome. So let's do a comparison. Let's see if these are equal strings. And they are true. That is true. The next thing we need to know are conditionals and branching. Your Python program is read into the shell and executed from the top line of your program down to the bottom line of your program. And then if it runs into a condition, it will evaluate the condition And if that condition is true, it will branch into different directions of the code on different indentation levels, and it will execute that piece of code. Here's a fork. So here are the conditional operators. There is less than, greater than, less than or equal to, greater than or equal to, equal, and not equal. So if we're comparing integers or strings, and then these evaluate to true if A is greater than B, A is greater than or equal to B, A is less than B, A is less than or equal to B, A and B are both equal, A is not the same value as B. So this is what a branch looks like. Depending on the result of the comparison of the code, it can branch into different paths. So this is the most basic. We are just setting a variable, and if it's true, if A is true, then it will go and execute the code on this indentation level. If not, this code will not be executed. So then there is also an else condition. If A is true, print A is true. Else, print A is not true. The else gets executed if A is false. So we'll see the output, A is true. So then if A is false, the else statement will run. So the output would be A is not true. So here we can show an example of three conditions. First there's an if, then there's an elif, and then there's an else. So on the first one, we have A is false and B is true. So if A, print A is true. If B, so else if B is true, we print B is true. And then else, neither are true. So it looks like B is true. So let's check the output. B is true. So now we are setting both of them to false. Same code, and then output neither are true. So else is what you want. You use else pretty much as your last option. If nothing correct ran in your program, you would use the else to branch off to decide what you want to do if nothing else evaluated to true in your program. So lastly, there are also logical operators. So we have another variable A, which is true, B is true. You can also make a condition of not A. So not A would evaluate to false. It is just the opposite of whatever the value of A is. And then you can also check if both A and B are true, which is true. If one of them are false, then this would evaluate to false. Now let's switch A to false. So B is true, A is false, and there's also an OR statement or operator. And C, then we would only need one of them to be true for it to evaluate to true. If A and B were both false, then this would evaluate to false. But since one of them are true, then it evaluates to true. So I wrote this program to tie all of the concepts together that we've learned. So first line is this variable email, and there's an input function. The input function prompts something to the screen, whatever is inside the parentheses, so it will say enter your Gmail address. And then it will store whatever you type into the terminal and press enter as this variable. And then it will prompt you for a password and another password, and then it will run some logic on what you gave it. So the first thing it does is it checks if the end of the email address is correct. So we take our variable email and then we index into it backwards. So we index it to -10 which is the length of @gmail.com. And then we do a colon and then to the end of the string. And then there is the not equals operator. So if the end of the email, if the last 10 characters of the email do not equal @gmail.com, it will print this is not a valid email. And then next, it will check if the passwords are not the same. If they're not the same, it will print passwords do not match. And then last, it checks if the password is long enough. So it checks if the length of the password is less than 4 characters, it will say password is too short. Last, it will say account created if everything is correct. So, oops. Okay, so let's run this program. Python 3, that's question.py to jesse@gmail.com, password, and then boom, account created. So all of these things were valid. I'll show you what happens if they're not. So let's go Joe 3, and then password, hello, and then let's go pi. So the first thing it catches is it's not a valid Gmail. And then the elifs do not get run. So the first thing it checks is if it's a valid email. But since this turned out to be true, none of the elifs or the elses get executed. So if we let's do that again, but then let's do joe@gmail.com and then a password 2. Oops. Passwords don't match. So the other thing you can do is you can make them all if statements, and then it would show all of the results. So let's go Joe at let's go msn.com, and then pass 1, pass 2, and here all of the if statements get checked. So it's not a valid email, passwords don't match, and then it looks like the else did get run, but that's because the password was long enough. So yeah, that was the only thing I was checking. So that is it for this video. I'll see you in the next one. Thanks.